Hello everyone, welcome back to Let's Unbound. We are in 15th episode of the series. With this, the concept review will be over, and there will be one more video, that is 16th episode, which is unit review problem, like an exam style problem of the unit 3, right? So let's start with 3.15, which is rates of change in polar functions. We already understand what is polar function. Polar function is in the form r equal to f of theta. R is distance from the origin and theta is the angle from the positive x-axis or the polar axis. So this in polar functions also we can calculate the rate of change. That means finding how a quantity uh, changes, like y changes with respect to x, like in our Cartesian system, right? In polar system, how quantity r changes with respect to theta or theta changes too. So one changes with respect of the other. Often we will consider the time t, right? So here, rate of change formula for a polar function. How radius changes with respect to theta. So this del represent this triangular shape, right? This represent uh, rate. So rate of change in r divided by rate of change in theta. R is nothing but f of theta, right? So two intervals, average rate of change, in the sense they will give the two like an interval with two endpoints. So we can, if it's theta 1 comma theta 2, if you're solving for average rate of change, f of theta 2 minus f of theta 1 divided by theta. It's very much relatable to what we learned in our regular coordinate system. Right, so what is del r? Change in radius. Del theta is change in angle. Theta is just an angle. F of theta is the radius at that particular angle. The other things and very simple formula. Now, characteristics of polar function. We will be using these characteristics while solving problems on rate of change. The general form of polar function r is f of theta, r is distance from origin, theta is angle from positive. I repeated this many times. Now, symmetric test, polar axis symmetry will be satisfying this condition. F of minus theta is f of theta, then it's symmetric about x-axis or polar. Vertical axis, f of pi minus theta equal to f of theta, symmetric about y-axis. So pole, origin symmetry, f of theta plus pi equal to minus f of theta. This is origin symmetry. Right. So the conditions for polar axis is this, and vertical axis is this. Pole symmetry is this, origin symmetry. Check before plotting to save work. And common shapes we know already, we come across, so just take a look. And rose petals count also we know, k odd means k are the same. If k is even, 2k petals. Periodicity, a function repeats for a certain theta and interval. For example, we did rose curves period is pi by k. Negative or how we will plot, we will plot it in opposite direction of theta. This will create one extra symmetry, right? And polar radius behavior, if r is positive and your r is increasing, then polar radius, like the distances, it moves towards your point will move outward, right? When r is negative and r is increasing, it moves inward, that it's getting closer to the pole. And r decreasing or positive moves inward, closer. R is negative, R is decreasing, moves outward. So this also we will be using. Mostly distance from the origin to the point, whichever we have taken, we will apply this. Let's go for questions. Determine the symmetry of the polar curve. So this polar curve represents a circle. As we know, r equal to a cos theta represents a circle, and it's a horizontal circle. A circle that lies on x-axis. X-axis symmetry it will have. So let me check the symmetry. First is polar axis symmetry. How will I do this? F of minus f of theta is 4 cos theta. And I will solve for what is f of minus theta. F of minus theta is 4 cos negative theta. Cos of negative theta will be negative theta is fourth quadrant. In fourth quadrant, cos is positive, so 4 cos theta. And yes, f of theta and your f of negative theta, it's being same, 4 cos theta, so they are equal. If this equals f of theta equal to f of negative theta, then I will say, yes, that is a polar axis symmetry. Okay, the curve is symmetrical about polar axis means x-axis. Okay. Second condition, is it symmetric about y-axis like theta equal to pi by 2? So now you have to apply the condition f of pi minus theta. So it's 4 cos pi minus theta. Pi minus theta means it is in second quadrant. It's cos negative there. So minus 4 cos theta. So f of pi minus theta, I should get f of theta. Then only I will say. But I didn't. I got negative f of theta. So there is no um, not symmetric about y. If I get f of theta, it's symmetric. So it's not symmetric about theta equal to pi by 2. Like in polar coordinate way, I won't say y-axis, but I will say theta equal to pi by 2. Right? Next part. There is origin symmetry also we can check. Origin symmetry or pole symmetry. So origin symmetry, what I should do is replace your r comma theta with minus or 5 plus theta. Okay. So this is my r equal to 4 cos theta. Let's, in place of r, put minus r. In place of theta, you're going to put 5 plus theta. And solve for it. Minus r is 4 cos pi plus theta. So pi plus theta is this part and this is tan and cot tangent is positive. So cos will be negative. So negative cos theta. Okay, you simplify this, you will get back the same equation. Then we are telling, yes, there is an origin symmetry. So symmetric about the pole or symmetric about the origin. So it's symmetric about, not it's symmetric about polar axis, it's symmetric about pole, but it's not symmetric about the line theta equal to pi by 2. Right? And with this, we are moving to question number 2. Consider a polar function r equal f of theta. Assume theta increases in the polar coordinate system on the interval. So we have to assume theta is increases in this interval. You're told that f of theta is less than 0 and f of theta is decreasing on the interval. So f of theta is negative. Also, it's decreasing on the interval. Now, which of the following statement is true about the distance between the point with polar coordinates f of theta and theta and the origin? So there is one point and origin. What is the distance between them? Like the true statement which describe the distance between these 2 points. Okay, what is distance? Distance between your point and origin is its modulus of f of theta, because we can use negatives also. That's why we are using modulus. I mean the absolute value. So what is given to us? F of theta is less than 0. Also, f of theta is decreasing. Less than 0 means what you will do? Negative values. It decreasing means minus 3, minus 4, minus 5, like that. It's decreasing. Correct? So it's become more negative. This is what I understand. Now, what happens if you take modulus f of theta? It will go 3, 4, 5. Like they will become positive. So this is what they given. And when I check modulus, modulus means the distance between the point and origin, whatever they had asked, it's becoming positive also because distance, right? So distance is positive and it's increasing. Can you see 3, 4, 5? So the distance is increasing on this interval. The distance is increasing on that particular interval, pi by 3 less than or equal theta less than, because I use the information given on that interval. So I can say it's increasing only on that part. So it's option C. Okay. Hope this is clear, right? So very simple. And there is a bonus question, which is literally like this. So if you didn't understand, pause the video and try to understand. And we are moving to last final question. Consider the polar function r of theta, it's minus 3 sine 2 theta. The table gives some values and you can see it here. Is f of theta equal to r theta increasing or decreasing on this interval? Is the distance between the point and the pole increasing or decreasing on the interval? On which interval is f changing faster in rate? 0 pi by 12 or pi by 12 to pi by 12? Let's solve. First question. So they are asking your f is increasing or decreasing. So you just, this is your f of theta. Actually, it's minus 1.5. Okay, just change this. Even though the stable value is not given, you can just use calculator in that case, right? So let's solve this. So 0 to 5 by 4, what happens? 0 to minus 1.5, decreasing, more negative, more negative. So it's decreasing, correct? So f of theta is decreasing on that interval. On 0 to 5 by 4. Very simple, right? Just by observing. If table is not given, you should tabulate this and you can guess this one, right? And next part. Is that distance between the point and pole increasing or decreasing? We know what is distance between the pole. Modulus or, right? So is it increasing or decreasing is the next question. So let's understand f of theta because or means what? Modulus f of theta. I mean absolute value of f of theta. Let's see how f of theta goes on this interval. F of theta it's decreasing. F of theta goes like 0, negative 1.5. It's decreasing and this way. So when you take modulus f of theta, what happens? 0, 1.5, 2.59 and 3. So your modulus, that means what? Distance, right? Distance between your point r comma theta and pole is increasing. 0, 1.5, correct? Is increasing as we can see it here, right? So I will say it's increasing on. So distance is increasing on this particular interval. So that's how this works. Okay, right. And the last part of this question, on which interval is f changing faster in rate? So we should find rate of change and then we should compare and find which is faster. So 0 to pi by 12, you will find average rate of change. Okay. So average rate of change, I'm writing A or OC, average rate of change in the interval 0 pi by 12. So what will you do? That would be equal to del R by del theta equal. So pi by 12, it's kind of minus 1.5, 0, 0. And then pi by 12 minus 0. Rest you can use calculator for this and you will get approximately negative, wait, let me do it here. Negative 5.7296 like this. Next, I will find average rate of change on the another interval 12, 5 by 12 comma 5 by 4. So del R over del theta is going to be pi by 4, it's minus 3. Formula has a minus, pi by 12 is minus of 1.5 divided by pi by 4 minus pi by 12. You can directly go for calculator or simplify. Minus 1.5 and pi by 6. And you can further simplify this. You will get negative 2.8648. Okay. So this is what I got. Average. So okay, this is how the one quantity changes with the other. Correct. Now how, on which interval f is changing faster? So this is more steeper, right? Like for example, it's 57 over 10 means for every 10 units, 57 dropping. This means 28 over 10. I'm just approximating. 28 over 10 means every 10 units, 28 only drops. So which is steeper means the more the drop, the more steeper. So this is more steeper and hence it changes faster, right? So more steeper is the faster one and yeah, you can say. So the faster change is faster change is in the interval, the first interval 0, 5 by 12. Right? So this is how this works. And that's it. We completed the 3 questions, which plays a very important role in understanding this topic. And yes, I have a bonus question to you. So take a screenshot of this and do try this and give your options in the comment section. Also, share your feedback, suggestions, and what else you need from Let's Unbound side in next video or new playlist, right? So that's all for today. Keep learning, keep practicing. Thank you for joining. And yes, we have one more video waiting uh, for you, like that is based on exam style problem on Unit 3, right? Keep learning, keep practicing. Let's meet in next episode of the same playlist. Thank you. Stay curious.